Hi everyone, in today's video we're going to look at minimal spanning trays. We're going to start with how do we define a tray in a graph. A tray is a connected graph that contains no cycles, multiple edges, or loops. A tray may be a part of a larger graph. So the first graph shows an example of tray. As you can see, we don't have any loops, multiple edges, or cycles. Second example is still a tray, but the last graph is not a tray. As you can see, it contains a loop. It also has a cycle and multiple edges. So in a tray, if you are given n vertices, then for the number of edges, we can use the root n minus 1. Okay, let's go back to have a look at graph 1. So for graph 1, if we count the vertices 1, 2, 3, 4, 5, 6, 7, 8, we have 8 vertices. Then for the number of edges, we have 1, 2, 3, 4, 5, 6, 7. As you can see, we have 8 vertices. Number of edges is 8 minus 1, which is a 7. Okay, so same idea will apply in the second graph as well. Number of vertices, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The number of edges will be the vertices minus 1. So we have 11 vertices and 10 edges. The formula between the vertices and the edges apply to any trays. Another important fact about trays is that every connected graph contains one or more trays. This is a connected graph. You could find two trays, so the tray colored in red and also the tray colored in green. You can also find other trays in this connected graph. So they are the two examples we have here. Okay. Now let's put it into practice. Question 3. Which of the following graphs are trays? Think about, for a tray we cannot have loops, we cannot have multiple edges or cycles. Okay, I'm going to give you 5 seconds to think about. Yeah, I guess everyone have got the answer. The answer should be I, should be B. C, we have a cycle, so it is not a tray. And we also have D and E again. We have a cycle here, and then we have a loop there. Now let's keep going. After we know how to define a tray, we're going to look closely what spanning trays. A spanning tray is a tray that connects all of the vertices in a connected graph. So for example, in this connected graph, we could find a spanning tray colored in red. As you can see, for this tray, it contains all the vertices in this graph. So let's have a look one practice here. For the following graphs, draw 3 different spanning trays. So I just put one example here, which is B. Remember, for a spanning tray, you have to include all the vertices in this graph. So what I'm going to do is, firstly, I'm going to put down all the vertices. So I put down all the vertices, and I just need to use the edges I'm given to connect all the vertices. Just keep in mind, as you can see for this connected graph, you are given some cycles here. So make sure you don't connect the vertices with any of a cycle here. So I can draw a spanning tree look like that. Okay. Again, I draw all the vertices, then connect them with the edges we're given. Then the last example, so a spanning tree could look like that. Okay. Once we understand spanning trays, let's move on to minimum spanning tray. From the name, you probably could tell that minimum spanning tray we will need to apply our understanding of weighted graphs and networks. For weighted graphs or networks, it is possible to determine the length of each spanning tray by adding up the weights of the edges in the tray. So from the previous video you learned, the weights will be the numbers that added or attached to each of the edge. For this spanning tree that we had before in this connected graph, if we add the weights, then to work out the length of the spanning tree, we're just basically adding up the numbers that attach to the red edges will be 22. A minimum spanning tree is the spanning tree of minimum length, so maybe minimum distance, minimum time, or minimum cost. There may be more than one minimum spanning tree in a weighted graph. That's all I would like to talk about today. Next video, I'm going to share with you the strategy we are going to use to find the minimum spanning tree. So there are some steps you can take to help you to work out minimum spanning tree. That's all I would like to cover for this video.